Hi, welcome to Petradot. And in today's video, we will explore how the computer actually works, what happens inside when you run a program, how the CPU and memory communicate, what interrupts are, and how multitasking allows your computer to run several things at once. By the end of this video, you will understand the core idea behind every modern computer. And this knowledge will help you as a beginner in software engineering or computer science at any level, whether you are studying for your degree, master's, or PhD. But before we dive in, please make sure to subscribe and turn on the notification bell so you don't miss future videos where we will break down programming and computer science concepts in a way that is fun and easy to learn. Beginning the journey as a software engineer when you start learning about computers, it is helpful to have a mental map of what you'll be learning. Just like any other journey, knowing where you are headed makes everything easier. So in this lesson, you will learn the basic of what computers are, how they work, what a computer program is, and how it is executed. Don't worry if you don't understand every single detail yet. The goal here is to get the big picture. You will meet all these ideas again in greater details as you continue your learning here. To make it easy to understand, I will break down each explanation into subtopics. 1. The fetch and execute cycle. Let's start with the machine language. At the center of every computer is a powerful component called the CPU, or central processing unit. Just think of it as the brain of the computer. It is responsible for carrying out instructions and performing calculations, which in our terms, this group of instructions is called a program. A program is simply a list of clear step-by-step instructions that the computer follows automatically to perform a specific task. These instructions are written in a very simple language known as machine language, made up of just zeros and ones. Each computer type has its own machine language, and it can only directly understand programs written in that language. Programs written in other languages like Java and Python must first be translated into machine language before the computer can execute them. Now, when a program is running, it is stored in the computer's main memory, also called the RAM. This memory holds both the program's instructions and the data the program uses. The memory is organized into numbered locations, each with a unique number called the address. The CPU uses these addresses to find specific data or instructions. It can also store new information back into the memory by specifying the address where it should go. The CPU repeatedly performs a simple cycle: fetch an instruction from the memory, executes that instruction, move to the next instruction, and it repeats these steps. Now, this constant loop of fetching and executing is known as the fetch and execute cycle, and that is the fundamental process that makes every computer work. Now, inside the CPU are small high-speed memory units called registers. One of these is the program counter, which keeps track of where the computer is in the program. It stores the address of the next instruction to be executed. But then, how does the computer or the CPU understand these instructions? Here is the interesting part. The CPU doesn't understand instructions the way humans do. It simply reacts based on how it is physically built. Look at it here. A computer is made up of millions or even billions of tiny electrical switches called transistors. These transistors can be turned on or off, representing binary digits, 1 or 0. When a machine language instruction is loaded into the CPU, it changes the pattern of which transistors are on or off. So the CPU is wired in such a way that this pattern automatically triggers the correct operation, like adding two numbers or storing data in the memory. So in short, programs and data are stored as binary numbers in the memory. The CPU fetches these binary instructions one by one and executes them mechanically. So because the CPU has no understanding, programs must be precise and unambiguous because the computer does exactly what you tell it to do. Okay, now let's talk about asynchronous events, polling and interrupts. The CPU and memory are just two parts of a complete computer system. Other parts include the hard disk for storage, for long-term storage, keyboard and mouse for inputs, the monitor and the printer for outputs, etc. Then, all these parts, called devices, must communicate with the CPU. But the CPU only understands instructions. So each device needs a small piece of software called the device driver, which lets the CPU to control it. All these devices are connected by a bus, that is a set of wires that carry data, addresses, and control signals between these components. Now, sometimes the CPU needs to know when a device has a new data or an instruction. For example, when you press a key, one method is for the CPU to keep checking all the devices repeatedly to see if something has happened or instruction has been given, and this method is called polling. But however, polling wastes time, so instead computers uses what? Interrupts. An interrupt is a signal sent to the CPU by another device telling it that something needs an attention. Now, when an interrupt occurs, the CPU pauses whatever it is doing at the moment, quickly handles the event like reading your key press, and then resumes whatever it was doing before. This allows the CPU to handle asynchronous events, that is, things that happen at unpredictable times, efficiently and automatically. Now, let's talk about multitasking and threads. Modern computers are very fast, so instead of just doing one thing at a time, they can manage multiple tasks seemingly at once, which is called multitasking. For example, in your computer, you play music, download files, display time, and still at the same time you are typing a document. Each of these tasks is called a thread or a process. At any given moment, the CPU executes only one thread, but it switches between them very quickly, many times per second, and this gives the illusion that everything is happening simultaneously. When a thread is waiting for something, like a file to be downloaded or a key to be pressed, it can pause, holding the CPU to run another task in the meantime. This makes computers very efficient. Now, let's talk about the role of the operating system. The software that coordinates all this, the interrupt, device drivers, multitasking, and communicating between programs, is called the operating system, or OS. The operating system is what makes your computer usable. It makes hardware, memory, and programs. It manages the hardware, memories, and programs, allowing everything to work together smoothly. Common examples include the Windows, Mac OS, Linux, and the Android. Now, in conclusion, in this video we learned 1. That the CPU is the brain of the computer. 2. It runs programs stored in memory using the fetch and execute cycle. 3. Machine language instructions control what the CPU does one step at a time. 4. Interrupts helps the CPU respond to outside events efficiently. 5. Multitasking allows the computer to do several things at once. And the operating system ties everything together. Now, understanding this foundation helps you see what is happening behind the scenes when you write and run your first program. If you enjoyed this video and found it helpful, make sure to like, subscribe, and share it with your friends who are learning programming or computer science. Also, if you have any other idea or contribution to what we just learned now, or any question, use the comment section, drop your opinion there, and let us discuss. Stay tuned. Thanks for watching, and see you in our next video.